Good morning, Year 8. Thanks for engaging with our online lessons again. If you could please send me that message on Show My Homework so they can mark you down in the register, that would be amazing. And today's lesson is going to be assessed by some self-marking activities. Please get in touch with me as usual at red@theroyal.school if you need any assistance. And then if you want to submit work, you can do that via Show My Homework. So we're going to be continuing with our algebra work today, and we're going to be having a look at rearranging formulae. So developing students are going to be able to rearrange formulae that have one step in them. Secure students will be able to rearrange formulae that have multiple steps. And then our excelling students are going to be able to rearrange formula where the unknown appears more than once. So you've got some keywords at the bottom here about rearranging and formulae next to it with the singular and plural. The subject of a formula is going to be the letter that we want to be on its own. We've got our general words for our operations here that we've seen in previous lessons as well, such as factorise and expand, and most of the others we should have seen before, but get in touch if there's anything you're unsure of here. So start activity, I've got 3 equations for you to solve. So if you'd like to pause the video until you've had a go at solving these equations, and then I can run through the answers. So answers to these then. The first equation, we should have p equals 6. I'd be hoping that you'd be taking 9 from both sides of the equation and then dividing both sides of the equation by 2 to get that answer. Next equation, we've got an unknown on both sides here. So here I'd be maybe adding 16x to both sides, and then adding 2 to both sides, and then dividing by 20, and that will give you x equals a half. In the last one, we can follow the same sort of process, but we'd have to expand the brackets first. So we might have 3a plus 6 equals 26 minus 2a. We can add 2a to both sides, take 6 from both sides, and then divide by 5 to get the 4. So rearrange the formula to make x the subject. You'll have to see what that looks like in a moment. But when we're going to rearrange a formula, we need to remember that our same algebra rules apply as solving equations. So it's really useful for you working out to keep the equal signs in line. We're going to use inverse operations to get rid of anything that we don't want on one side of the equation. And we're going to keep the equation balanced. That means we're going to be doing the same to both sides of the equation, as you would with solving an equation. So rearranging a formula might look like this. We've got an equation here, a plus 4 equals b. The reason it's a formula and not an equation is because we've got more than one unknown here, and so it's a plus 4 equals b rather than a number. But the same process applies. If we want to make a the subject, we want a on its own. So we need to get rid of anything else that isn't a from this left-hand side of the equation, and then we'll have rearranged the formula. So we won't have a final number answer like in an equation, but there'll be an algebraic expression there. So how do we get the a on its own? Well, you can see that after the a, we've got a plus 4. So if you're going to get a on its own, we need to get rid of the plus 4. So I'm going to take 4, but from both sides of the equation to keep it balanced. On the left-hand side, the plus 4 and the minus 4 will cancel each other out so that we only have an a left. And on the right-hand side of the equation, we're going to have b minus 4. And that's it. That's making a the subject. We've now got a equals, therefore a is the subject. So that's a one-step formula to rearrange. We can't simplify this any further because we've got our single term expressions here. We've got an a on its own, we've got a b on its own, and we've got the minus 4. There's no like terms to collect here, and there's no multiples of terms, so we can't divide or factorise. So another example, rearrange the formula to make c the subject. So we've got c minus 6 equals d. So again, if we want to get c on its own to make it the subject, then we need to work out what's happened to it. C has had a 6 taken away from it, so we've got this minus 6 here that we don't want on the left-hand side. So we need to do the inverse operation, the opposite function to that. So the opposite of minus 6 is plus 6, so we do a plus 6 to both sides of our equation here. So on the left-hand side, we've got c, and the minus 6 and the plus 6 will cancel each other out, so that just leaves us with c, which is fantastic. And on the right hand side we'll have d plus 6, so that's our right hand side, and that's it done. So rearrange this formula to make x the subject. We've got 7x equals y. Well, here we've got not just one x on the left hand side, but we've got 7 of them. Remember that number 7 there means that it's been 7 times by x to equal y. So if we start to think about the inverse functions there, we're going to need to divide by 7. The opposite of timesing by 7 is divide. So let's divide both sides by 7, and then 7x divided by 7 will just give us 1x, and y divided by 7, well, actually we're going to need to leave that as a fraction here. Remember, we don't like to write that divide sign or the times sign in algebra. So the 7x, remember, meant 7 times by x, and y over 7 means y divided by 7. So try and leave things as fractions where possible. So rearrange this formula to make m the subject. So here I've got m over 3 equals n. So if we want m on its own, we need to work out what's happened to it. M is over 3, so that means m has been divided by 3. The opposite of dividing by 3 is timesing by 3. So let's multiply both sides of our formula by 3. And then let's have a look at what we'd get. Well, m divided by 3 and times by 3, dividing by 3 and times by 3 are inverse operations, so they'll cancel each other out. So we'll just have m on the left-hand side. And then n times by 3 will give us 3n on the right-hand side. Remember, your number has to go in front of the letter when you're doing a multiplication there. And these are our steps that we would take then to solve these one-step formulae and rearrange them to make a different letter the subject. So now we're going to look at rearranging the formula to make t the subject. Here I've got r plus 4t equals s. So we've got a couple of things happening here, and we need to work out what's happened and in what order. So the fact that there is a 4 in front of the t means that t has been multiplied by something. We've also had r added to it. But what order did that happen in? Well, if you think about BIDMAS, then multiplication comes before addition. So our yellow multiplication must have happened first when we're describing what's happened to t. Now, unfortunately, though, when we are going to rearrange a formula, we're going to do those inverse operations, so we need to work backwards. And that means we actually need to work against BIDMAS. So if the last thing that happened to t on the left-hand side here was the green part, the adding r, then that's the first bit that we undo. So work actively against BIDMAS. We know that the last thing that happened was adding r, so the first thing that we do is subtracting r. And then let's work out what we need to do to our formula here. If we've got r plus 4t, but take away r, we're going to be left with just the 4t. And on the right hand side, s take away r, well, is just s take away r. Now we can undo the 4t part of this. We know that t has been multiplied by 4, so to undo that we need to divide by 4. But remember, it's the whole expression here, so we want the whole of s minus r to be divided by 4. So make sure you're very clear that the whole expression that you had on the right hand side is now being divided by 4. And then let's simplify this then. 4t divided by 4 is just t, and then this right hand side s minus r divided by 4, well, it's going to have to stay exactly the same, there's no way of simplifying that further. And that's a 2-step formula rearranged. Let's look at a few multiple choice ones then before we continue. So here we have some formulae that may well be used in real life. So here we have Ohm's law from physics, which is V equals IR. And then I would like you to try and work out, well, what would the formula be if we wanted I as the subject? So we've got I equals here to show us that we want I to be the subject. So I'll leave you for a moment to work out what the formula would be, and we'll run through the answer. Okay, so in this case, we should have a V over R. You can see in the original formula that I has been multiplied by R. I, R are next to each other. So to undo this, we need to divide both sides of our formula by R, and that'll leave us with V over R on one side. So now we've got a volume of a cylinder formula, and I'd like you to work out what the formula would be if we made H the subject in this formula. So pause until you've had a think about this, and we'll run through the answers now. So here we should have V over pi r squared. Now there's a little shortcut to do with this one. If we want H to be the subject, we can see that on the right hand side of this formula here that H has been timesed by all of pi r squared. So actually you could do that all in one step. Divide both sides of our formula by pi r squared, and then we end up with v over pi r squared as our answer to this, equaling h. Next formula is a velocity formula, v equals u plus at. But I'd like you to work out what would happen if we made t the subject. So again, pause the video until you've had a bit of time to think about this. And here we should have v minus u over a. So if you have a think about this formula, we've got two things happening. The letter t has been multiplied by a, and we've also added u to it. So remember, work against BIDMAS here. The first thing we would do is take away u from both sides. That gives us the v minus u part. And then to get t on its own, we'd now need to divide by a. So it's all of v minus u divided by a as our final answer. Now we're looking at the area of a triangle formula, one you should have used many times. Area equals a half base times height. But what would this formula look like if you made the base the subject? So b equals. So have a look at this and unpause the video when you're ready for the answers. So for this formula, if you want b to be the subject, you can see that it has been multiplied by a half and it has been multiplied by h. So we need to undo those two things. So we actually need to divide by a half and divide by h on both sides of the equation. So that would be a divided by a half and divided by h. Well, actually we haven't got anything with a half in here, so you've got to remember that dividing something by a half, finding out how many halves go into it, is the same as timesing by 2. So we could rewrite this one as a times by 2 and divided by h. So we should end up with a middle one here. A has been times by 2 and then we've divided by h. Another one then, area of a trapezium. So our area is a half brackets a plus b h. And you should have used plenty of times as well. But what if we tried to make a the subject of the formula? What would the formula then look like? Again, a few moments for you to try and rearrange this yourselves, and then we'll run through the answers. So, answers to this. Let's have a look at the 3 steps that we would have taken. So, the letter A that we've got on its own. First off, we've added a b to it. Secondly, we've timesed everything by a half. And thirdly, it's then been times by h. So we'd need to reverse things in that order. The blue and the purple ones are interchangeable because they're both multiplications. So if we got rid of the blue first, then we'd have to times by 2 on both sides. So that gives us 2a. We then get rid of the purple part, the timesing by h, that's divide by h, so we'd end up with 2a over h. And then lastly, we'd get rid of the first thing that happened to a, which was the adding b, because it's in the brackets. So that's the last thing we get rid of. So we're going to end up with 2a over h, all take away b. Now, be careful with this one. It looks very similar to the one that we've got here in the top left, but we are definitely doing that division before we start taking away b. So it's the last one here. We can't have the b as part of that fraction. So be very careful on how that one's written. And Pythagoras theorem, depending on where you are in your curriculum, you may well have seen this lots of times or only a couple of times. But Pythagoras theorem tells us a squared plus b squared equals c squared. What if b was the subject though? And be careful, that says b on its own here, not b squared. So a moment to pause and think, then we'll run through the answers. So for this one, we should have the middle one again. If you can see here that b squared has had a squared added to it. So the first thing we would do is to subtract a squared from both sides. So b squared equals c squared minus a squared. And then if that would give us b squared equals something, well, we need to get b on its own. And the opposite of squaring a number is to square root it. So we've got a square root over the whole expression of c squared minus a squared there. And make sure it's really clear that that top line of the square root sign goes all over the expression. So now we move on to activity 1. So activity 1 is a bit of a card sort. Now this will depend on how you are doing it. If you've printed this off and are working in your exercise book, that's very easy because you can just cut these out and rearrange them. If you're working on a computer file, you might be able to copy and paste those into lines that are next to each other. And then if you're just working on paper, then you can actually just rewrite these expressions and formulae next to each other as appropriate. So what we want is, for when we check through the answers, I'd like you to start off with a C equals formula, and then we're going to try and match it up next to it with a D equals formula. Now obviously this is the jumbled up version, so these don't match, but for example here, if I was doing this first one, if we want D to be the subject of the formula, we can see on the right hand side here that D has had 3 added to it, so we need to take 3 from both sides in order to get D on its own. So it'd give us C minus 3 equals D, or D equals C minus 3. And then that is over here. So I need these two formulae matched next to each other somehow. As I said, whether you're cutting them out or rewriting them or copy and pasting them on a Word document is entirely up to you, but try and match the C equals formula with the D equals formula for it. And if you'd like to pause the video until you're ready for some answers. So let's run through what we should have. I've got working out with all of these, so you may want to pause at any point just to have a look at what we should have been doing with these. So there are 3 here that we should have matched. The first one that we went through, take 3 from both sides. The second one I've got here is another one-step formula. We've got D minus 5, so we add 5 to rearrange the formula. And then the third one here, we've got C equals 2D. So again, we've got a single step formula, but we need to divide both sides by 2 in order to get D on its own. The next 3 then, we've got the final single step formula, C equals D divided by 3, so times by 3 on both sides to rearrange the formula. Number 5, we've got our first 2-step formula. So here D has been multiplied by 3, then we've added 2. Remember that would be the bid mass order for things, so when we're reversing we go against bid mass order. So we've taken away 2 first, and then finally we've got rid of the times by 3 by doing the divide by 3 opposite function. And be careful on how that's written as the fraction there. And then number 6, we have another 2-step formula. So D has had 2 taken away from it, and then we've divided everything by 5. So remember, work in reverse bid mass order. The first thing we do is get rid of the divide by 5 by timesing by 5, and the second thing we get rid of is the take away 2 by adding 2 to both sides for that. And then the last 2 here with these 2-step formulas. So again here, let's have a look at what's happened to D in question 7. D's been multiplied by 2, then we've taken away 5. So the first thing to do is get rid of the last part of bid mass, so get rid of the take away 5 by adding 5. And then we get rid of the times by 2 by dividing by 2. And the last one, what order did things happen in? Well, first D has been divided by 3, and secondly we've taken away our 17. So let's reverse the bid mass order. We're going to get rid of the take away 17 by adding 17, and then we're going to get rid of the divide by 3 by timesing by 3. Now it would be fully okay if you expanded those brackets and had D equals 3C plus, and actually did 3 times 17. But in this case there wouldn't have been an expression to match that, so we've left it as the factorised version here with the 3 times C plus 17. We are now moving on to our excelling student learning objective. So we're going to look at rearranging formula where the unknown appears more than once. So there is a step-by-step guide here of what to do. So firstly, we're going to highlight the unknown that needs to be the subject of the formula. And be careful because this is going to appear now more than once in our formulas. We now need to move all of those terms that contain that unknown to one side of our formula. Remember, it's going to appear more than once, so there'll be several of these expressions to move over. Thirdly, separate out the required letter on its own, and this step might require some factorisation. And then we can get our formula to that subject. So here, rearrange the formula to make T the subject. So our first step was to highlight those terms that include this letter T. There we go. The second step is to move them onto one side of our expression or equation, sorry. So actually, yeah, the RT and the 4t are both on the left-hand side of the equals, so that's fine. They're already moved over. And the next step is to isolate them on their own, and this can be done via factorisation. Both of these terms have a t in them, so we can actually factorise out the letter t and rewrite the expression. So t brackets r plus 4 equals s. Now remember, a bracket next to a letter or with a number in front of it means there's that hidden time sign. So this actually means t times by r plus 4 on the left hand side. So to get t on its own, we need to divide by all of r plus 4. So that leaves us with t equals s over the whole expression r plus 4. And that's rearranging our formulas where we have the unknown appearing more than once. So it's going to involve this factorisation in order to get the letter on its own. Another example of this one then. So rearrange the formula to make m the subject. So we've got am minus 5 equals nm plus 8. So our first step is to highlight those terms that have the letter m in them. There we go. And the second step is to move all of those onto one side of our equation. So I'm going to go for the left hand side here. It's entirely up to you to decide which side they go on, but I'm going to go for the left. So I now need to move this nm over to the left hand side, and to get rid of that nm I need to take away nm from both sides. So that gives me am minus nm minus 5 equals 8. Now having a look at my equation, I don't actually want this minus 5 on the left hand side. All I wanted on the left hand side are my expressions or terms that have m in them. So I now need to get rid of this minus 5 because it doesn't have an m in it. So I'm going to add 5 to both sides. So this is a really nice point to be at now in rearranging our formula, because I've got two terms here that have m's in on the left hand side, and then I've got my other terms on the right hand side. So now I can isolate my m letter out of there by factorising again. Both of these terms on the left hand side have an m in them, so let's factorise m out. We end up with m brackets a minus n equals a plus 5. Remember, that's the hidden time sign there. M has been multiplied by that set of brackets, a minus n. So what we can actually do to get m on its own is divide by the whole set of brackets. Divide by a minus n. And this gives us our final expression once we tidy it up. Remember, these two expressions, if we've got a times by a minus n and a divide by a minus n, they're going to cancel each other out. So it gives us our final formula of m equals a plus 5 over a minus n. It doesn't matter that a appears more than once on the right hand side, because that's not our subject. If m appeared more than once at the end, then we wouldn't have made m the subject. So m has to be on its own. Great. The a and the other letters can appear more than once if need be. So that's rearranging these formulae where the unknown appears more than once. So I'd like you to decide how confident you feel with this topic then. And as usual, we can decide whether we are going to have a go at the red activity, which is our very supported and frameworked activity, amber activity, where there is a little bit of help, or our green activity if you're really confident and are going to have a go at these with zero help at all. Remember that the red, amber and green are all the same questions, so there's no need to do more than one colour on this because they're all the same questions and the same answers. It's just that level of support that you get with this. So have a look at the correct activities. Again, we're going to run through the answers. This is a little bit more difficult. Generally, quite a few people do have problems with rearranging formula, so I am going to go through the answers in a little bit more depth on this. So self-mark definitely, but also follow through the steps that we should have taken on these. So unpause the video when you're ready for your answers for activity 2. Question 1 then, make x the subject. So we've got x plus b equals c. If x has had b added to it, then we need to just take b off both sides to rearrange our expression. A one-step formula to rearrange here. And part b, one step again. X has had c taken away from it, so we undo that by adding c to both sides. We then move on to some two-step formulae to have a look at. Here x has been times by 2, then we've added 4. So we go against bid mass. The first thing we undo is the plus 4, so we take 4. And then whatever expressions we're left with to get x on its own, we now get rid of the times by 2 part, so we divide by 2 and then simplify where possible. The same with part D. It's actually the same steps as part C, but we have just pure letters in this. So x has been times by a, and we've added b. So let's go against bid mass. The first thing we do is reverse the plus b by taking away b, and then we get rid of the times by a by dividing by a, and that gets us our final expressions. Number 2, we've got some more two-step formula here to make x the subject. So again, what's happened to x? Well, x has had 3 added to it, and then we've divided by 2. Now, just be careful on bid mass here. Bid mass normally tells us that division comes before addition, but as you can see, that x plus 3 is the numerator of the fraction here. The x plus 3 must have happened first before we did any division. So x had 3 added to it first to make the numerator, and then we divided everything by 2. So the first thing we do is times both sides of our equation by 2, and the next step is that we get rid of the plus 3 by taking away 3. B here, it looks very similar to A, but so be very careful about this fraction here. So as you can see here, actually the first thing that happened to x was it's divided by 2. So in this case, our division did happen first because it's only that single x divided by 2. And the second thing that happened was the add 3. So the first thing we do here is take away the 3's. And then the last thing we do is reverse the first thing that happened. The first thing that happened to x was dividing by 2. So now we times by 2 to get rid of that. And again, you could rewrite that as the bracket version there, or you could have expanded the brackets if you wanted to get 2b minus 6. So part C here, what's happened to x? Well, first off, because it's in the brackets, we added a, and then secondly, we times by 2. So first step to reverse is the times by 2, so we'll divide everything by 2, and then we get rid of the plus a by taking away a, and so on. So part D here, we can see that x, first off we took away b, and then next we divided by 2 in that order. So the first thing we do is get rid of the divide by 2 by timesing by 2, and then we get rid of the minus b by adding b. Number 3, this is where we step up to the expressions where we now have the unknown appearing more than once. So to make x the subject, so we can see here that x is in every term on the left and nothing on the right, so that's absolutely great. So we can now factorise out our x's. So x brackets a plus b equals c is our first step. Then we can say that x has been times by a plus b. So to get x on its own, we divide by a plus b, and that gets our expression. Part B then, we've got ax minus bx equals d. Again, our x terms are on the left and there's no x terms on the right. This is fantastic. We can just factorise straight away to give us this x brackets a minus b equals d. If x has been times by a minus b, we can undo that by dividing by a minus b, and that gets us our final expression. In part C, our x terms are not all on the left-hand side. So actually, the first thing we're going to do is take away x so that we can move this x on the right-hand side over to the left. So that gives us ax minus x equals d. Now you can factorise out. So that gives us x brackets a minus 1 equals d. If x has been times by all of a minus 1, then we divide by a minus 1 to get it on its own. That gets us our final expression. And very similar with part D here. Our x terms, we've got ax over on the left and cx over on the right. So the first step is to take away those cx's. So we move all the x terms to one side, the left. But then we've got ax over here and cx over here, which is great. But we've also got this plus b. So that's not an x term, so we're going to move it to the right-hand side by doing the opposite. So take b from both sides. That leaves us with ax minus cx equals d minus b. And we can now factorise out x brackets a minus c. If x has been multiplied by all of a minus c, we then divide by a minus c, and we get our final expression. And the final questions there, these are some more complicated ones because they involve the square roots in this. So here, x squared plus 4 equals a. Well, to get the x part on its own, we get rid of the plus 4 by taking away 4, and then that gives us x squared equals a minus 4. But of course, we don't want x squared, we want x on its own, so we square root both sides. These are very similar. It's x squared minus d, so let's add d to both sides to get our expressions, but of course that gives us an x squared equals something again, so square root both sides. Remember to make that square root go all over the expression that we've got at that point. In part C then, we've got x plus 2 all squared equals b. Well, the first thing we've got is we've got x has had 2 added to it, and then we have squared in that order. Remember the brackets came first to get b. So the first thing we do is get rid of the squared by square rooting both sides. This means that only b is under the square root. We then get rid of the plus 2 by taking 2 from both sides. So watch out here, we've got x equals root of b minus 2, but it's very clear that the square root sign is only over the letter b, and that the minus 2 is separate from it. And then finally, we've got here in part D, the root of x plus a equals b. So what happened in this expression? Well, x must have had a added to it first because it's all under the square root sign. And then secondly, they must have square rooted. We know it's second because the whole expression's under the square root sign. So the first thing we do is get rid of the square root by squaring both sides. And then the second thing we do is get rid of the plus a by taking away a from both sides to get our final expression here. So there's quite a lot going on with these. Please get in touch with me at red@theroyal.school if you do need any help with this, because it is notoriously a topic that some people have some difficulty with. And number 5 then, we've got our final steps here. These are the most difficult ones because our x is actually, to begin with, it looks sort of trapped underneath a fraction. So we need to try and reveal it and get it on its own. So here in question 5, a minus 3 all over x equals b. The first thing we need to do is release this x from being on its own. So we're going to times both sides by x. And that gives us a plus 3 equals bx. And it's only from this point then can we actually start to get x on its own. So our x here in yellow has been times by b. So we now go and divide both sides by b to get our final expression. And part B here, we've got a over x plus b equals c. So the first thing we need to do is actually move all of our non-x terms over to the right hand side. So we're going to get rid of the plus b here by taking away b from both sides. And then now we've got a over x equals c minus b. We can release our x from being at the bottom of the fraction again by timesing by x. And then that's going to give us a bracketed expression then. So it's going to give us here a equals x brackets c minus b. If x has been timesed by all of c minus b, then to undo that we divide by all of c minus b and we get to our final answer here. And lastly, we get to the much more difficult ones. So if you got through these, then absolutely fantastic. These are the absolute top end of our work. So we've got making x the subject here. So x plus 3 over x equals b. Again, we've got an x trapped at the bottom of this fraction, so we can't really do anything until we've released that. So we times both sides by x first off, and then we have x plus 3 equals bx. Now we need to move all of our x terms over to one side. So it doesn't really matter which side you move them onto, but here, just so I only need to take one step, I've moved the x over to the right hand side. So we're going to take an x from both sides, and it gives us 3 equals bx minus x. That can be factorised, the left hand side here, bx minus x, they've both got an x in them, so it's x brackets b minus 1. If x has been times by b minus 1, we now divide by b minus 1, and it gives us our final answer. Now, last one then, this has got the most steps as you can already see here, but let's walk you through it. So the first thing we need to do is release this expression from the bottom of the fraction because it's got the x's in. So we're going to times both sides by x plus c. Now that means the left hand side is just x plus 3, just the numerator, but the right hand side is b brackets x plus c. At this point, we still haven't got all of our x's on one side. So what we actually need to do here is to expand the bracket on the left. So b brackets x plus c becomes bx plus bc. We then need to move all of our x terms onto one side of the equation again. Again, this time I'm going for the right hand side again, but it's up to you to decide this. So let's move this x over by taking x from both sides. And that gives us 3 equals bx plus bc minus x. As you can see here, not every term is an x term. We've got this plus bc, that's not an x term. So we take bc from both sides to move it over to the left. That gives us this expression here. Now you can see here that on our right hand side we've got bx minus x, so we can factorise that. They've both got an x in them, so it's x brackets b minus 1. And then we can see that if x has been times by b minus 1, to get it on its own we divide by b minus 1. That gets us to our final answer here, but a huge amount of steps going on with that, and well done if you managed to get that one yourself. So thank you for engaging with our online lesson again. Please send me that message on Show My Homework if you haven't already. Hopefully people have self-marked on this. I've still been getting quite a few people sending work in where it isn't evident that people have self-marked, and it's really important for me to help you out. If you can self-mark that work, please. And then of course get in touch with me if you've had any problems with this. Some of us might have had some problems with the question 6 at the end there. But up to that point, I hope people could manage through and understand the solutions that we've got. Hence, I put some more lengthy solutions in with explanations for these questions than I normally do. Thank you very much. I'll speak to you later in the week.